So the car hits yours, you also move forward with the same speed or amount of force which hits your car. And so if you don't have your seatbelt on, you can be thrown away through the windscreen. Okay, please, are you okay? If you don't have your seatbelt on, because of the magnitude of the force which hits your car, you can be thrown away through the windscreen. That is why you are advised to put on your seatbelt whenever you are in a car, so that it will prevent this situation of you being thrown through the windscreen. Please, are you okay?
Yes,
Are we okay?
please.
Good. So when a car accelerates, you also pose the motion by going forward. Now, the amount of force which will push this load backward depends on the force which is moving the car forward. The greater the force, the greater will you slide back. The lesser the force, the lesser will you slide back. So this force, this backward force is equal to what is causing the acceleration of the car. So the backward force is equal to the force moving the car forward, moving the car forward. So for you to get the amount of force which slide the car, you have to calculate this force which is accelerating the car. Now, what is this force? Newton is saying that every force is given by mass times acceleration. So the mass of the vehicle, which is 25, times the acceleration of the car, which is 2. And so this force, which is causing the acceleration of the car, is 50 Newton. Class, are you okay?
Yes, please.
Okay. So if this force is 50 Newton, then the amount of force with which the body will be sliding backwards would also be equal to this. This is also 50. Now, when the body is sliding back, what will be the direction of the frictional force between the load and the floor of the vehicle? When the body is sliding back, okay, what will be the um what will be the direction of the frictional force between the load and the floor of the vehicle? Yes.
To the right.
So because why? Why to the right? Yeah.
Because frictional
Why
force opposes the apply.
go? Go. So here we are looking at the motion of the body or the load. So if the load is moving backwards, the frictional force would also act oppositely. Okay. Now we are looking at the question says that what is the calculate the coefficient of friction between the load and the floor of the vehicle. Okay. So it means that for the body to just slide, okay, backwards, this backward force must be equal to the frictional force. What is the backward force? Frictional force is given by mu times reaction. Mu times reactional force. Okay. And we know this will be equal to mu times mass times gravity because it's on a flat on a horizontal floor. Therefore, the backward force of 50 is equal to mu times mass, which is 25 times gravity, which is 10. help me. Josephine, your hand is up. Josephine. Hello, Josephine. Oh, it's a mistake. Okay, here, help me find mu, the coefficient of friction. Help me find that value. What is the value of mu? So, where mu will be?
0.2.
Hello, Marco. Where have you gone off? Okay, keep on trying. All right.
0.2.
Okay, so mu is equal to 0.2, and this is the answer. Here we have 50 is equal to mu times 250. 250. Therefore, the coefficient of friction is 50 divided by 250, which is 1 on 5. And so that is equal to 0.2. That is the answer. Don't forget, coefficient of friction has no unit. It has no unit. Please, is that okay? Hello, is that okay? Oh,
Yes,
no
please.
response.
Yes, please.
Hey, all right. We'll solve another question. Josephine, I'm recording it. So you'll be on. If the network is bad, you can still have the recorded. Okay. Let's solve another question. Then we look at the inclined plane. I gave you a couple of questions. Okay, so in another question, exercise 4.14, we are told a mass of 6 kilograms. Do I clean the board? Do I clean the board?
Yes.
Yes, please.
A mass of so we are told that a mass of 6 kilograms rests on a rough horizontal table. So horizontal table, and we have a mass of 6 kg. Okay, rest on a rough horizontal table. If the coefficient of friction of the surface is 0.4, so here mu is equal to 0.4. Mu is equal to 0.4. Find the least force sufficient to move the body. Find the least force sufficient to move the body. Now, we are looking for the least force sufficient to move the body. Let's assume the force is P. When the force pushes this, friction will act in the opposite direction. Okay. Now, please here note the difference. We are talking about the least force that will move the body, and this is not the same as the force which will accelerate the body. These are two different statements. Okay, the least force move the body to move the body is just to slide, and sliding is that force which will just be equal to which will just be equal to the opposing force. A force just equal to the opposing force. Okay. Force to move the body is equal to the force which is equal to the opposing force, here friction. Then a force to accelerate the body. There is an acceleration. There is a net force. In one, the net force will be 0 because both the force moving the body and the opposing force here are equal. But in the case of 2, whenever there is an acceleration, there must be a net force. So here we expect the applied force which will accelerate the body, assuming is greater than frictional force F. So this is the difference between to just move the body and to accelerate the body. Class, are you okay? Are we okay?
Yes.
All right. Let me see. Okay, so I have Equia, Janice, Joel, Pra, Sio. Equia Batman is gone. So that's the difference. So if the question is about the force, find the least force sufficient to move the body, then it should be a condition of 1, where to move the body hello, are we there?
Mr. Avia,
Yes.
please, could you go over what you just said?
Okay. Joe, I don't know if you have the question. Do you have it? Joel, do you have the question? Hello? Joel and her.
No, please.
When I forward it to your mom, can you get it? All right. So the question is on the platform. You can pick it from there. But what I'm saying is, hello?
Sure.
Joe, I'm listening.
Sir, please, she's not home right now.
Okay, so when she I get you. When she comes, you can get a question. Okay, so I'm just going over. So what I'm saying is The question, a mass of 6 kilograms rests on a rough horizontal table. If the coefficient of friction mu 0.4, so the friction force coefficient between the table and the mass is 0.4. Find the least force sufficient to move the body. We are looking for the least force which will just be sufficient to move the body. And what I'm saying is that when the question talks about to move the body, least force, we can just move the body a little. It's similar to when I apply, there's a mass. Okay, as the mass, sits on the phone, it is stationary. What is that least force which will just move this mass? Just move it. Now, when it moves, it means that the force applied has overcome the opposition, the frictional force between the mass and the phone. Please, are you okay? So, in the case of the force just moving the mass, then the force applied, if it's speed, is just equal to the frictional force. Another question can be a force to accelerate the body. Free acceleration is is caused by a net force or a resultant force. Okay, so here in the first situation, the resultant force is 0. In the second situation, when I subtract the applied force, the frictional force from the applied force, there should be difference. So T minus F must give us the acceleration. So that's the difference between 1 and 2. Just move it, and when the body accelerates. Joel, are you okay?
Yes, sir.
Mr. Bia,
Hello.
please, can you have a situation where the R is not equal to 0?
Where the
R is not equal to 0.
where the R is equal to 0?
It's not equal to 0.
Yes, yes. There are lots of questions here. What by here? Okay, you will solve that question. So when we start looking at inclined plane, we'll start. I'll give you such a question. So in a situation like this, there must be acceleration. Okay, so P minus F is equal to, this is the net force. This is the net force. Okay, and the net force horizontal is always equal to M times A, mass times acceleration. So when you then you can find the applied force or what. But here you have to be given the mass and the acceleration so you can find the applied force. So there is such a question. Is that okay? So in this case, V must be equal to, okay, so you're looking, now we know frictional force to be equal to mu times R, and R is equal to mg. Okay, therefore P will be equal to mu times m times g. Let's substitute the values. Mu is 0.4. Gravity is 10. So you have 4 times 6, which is 24. So the force to just move the mass will be 24 Newton. Class, are we okay?
Yes, sir.
Mr. Dia, so 24.1 will accelerate it.
Come again.
Please, will 24.1 accelerate there?
Exactly. If the applied force is just greater than friction, the body would accelerate. So 24.1 would accelerate the body. Okay. I want you to try
Yes.
this. I'm giving you a trial work. Let me see how you can think through and work it out. Are you ready?
Yes, sir.
Are you okay? A body of mass 8 kilogram. A body of mass 8 kilogram rests on a rough surface. A body of mass 8 kilogram rests on a rough surface. If the coefficient of friction is 0.6, if the coefficient of friction is 0.6, find the least force, find the least force that is needed to cause the body to move. If the coefficient of friction is 0.6, find the least force that is needed to cause the body to move.
Mr. Dia,
Hello?
please, can you take a shot and send it to the group? The board is not so clear.
No, I dictated it. What is on the board? Eh? Okay, about man.
Mr. Dia, I just joined. I don't know.
Are you
Okay.
requesting for? It's on the board or the question?
The question you read.
I've sent it. If this is also not correct, I'll send you the short. So I've sent the solution to on the board, to the platform. Finish. Hello, finish. This is an easy question. We can't waste time on this easy question. Every apartment, every apartment.
Stadium.
I have.
Stadium.
I'm
Which
giving you
number have we solved?
5. Which of the questions? Okay, you are solving question 3. Question 3. So, okay, what is wrong with your network? Hmm?
$48 Newton.
You have 48. Okay, so let's see.
Yes, please.
Let's see. Adoma. Oh, hey, she's also gone. Okay.
Stadium.
I've had a question which also has an acceleration, and I've sent it to the platform. When we finish solving this, we'll look at it. A question that demands or requires acceleration. Okay. So our question is that, are you there?
Yes, sir.
A body of mass 8 kilograms rests on a rough surface. If coefficient of friction is 0.6, so the mass of the body is 8 kg. Coefficient of friction is 0.6. Johnny, are you there? We have to find the least force that is needed to cause the body to move. Okay, so if we are looking for the least force to just move the body, then the least force assuming is P must be equal to F. That's the whole initial attempt. So this is what they're looking for. F is the frictional force which would oppose the motion. So mu times M times G. What is mu? 0.6. What is mass? 8 times 10. So you have 6 on 10 times 80. Okay. 6 by 8 is 48 Newton. So the force which will just move the body is equal to 48 Newton. How many of you got this right? How many of you? Mention your names. Hey, how many of you got it? Who got it?
Me.
Please, me.
Janice, Pierre Guatman had it. Janice got it. Who else? Okay, okay. All right. The question I just posted, and I'm going through. The question I just posted to the platform. That is question. A particle of mass 50 kilogram is caused to slide by 450 Newton force along a rough surface. a particle of mass 50 kilogram is caused to slide by 450 Newton force along a rough surface. If the coefficient of friction is 0.5, find the acceleration with which the particle moves. This is move, okay? This is move. It's not just a slide. That word must be is a particle of mass 50 kilogram is caused to move by a force of 450 or by 450 Newton force along a rough surface. If the coefficient of friction is 0.5, find the acceleration with which the particle moves. Class, can you give it a try first? Can we try first? Can you try? Yes or no? If yes, you try. If no, we all look at it.
Sir, please can you repeat the question?
Yes.
The question is that a particle of mass 50 kg is caused to move or slide, okay, by 450 Newton force along a rough surface. Along a rough surface. If the coefficient of friction is 0.5, find the acceleration with which the particle moves. Find the acceleration with which the particle moves. And I want you to give it a try first, because I earlier explained to you the difference between when it just moves and then accelerates. So, apply the knowledge. Let's see what you can do. In about 2 minutes time, then I give back. Okay. So my time is 7:56. If it's 7:59, I'll come back to what you've done, then we move on from there. Two minutes. 2 minutes more. We are the mind there.
Yeah.
Are you on? Okay, so right there. Joel.
Yes, sir. Sir, please, I can't hear you.
I'm asking if you are trying.
Sir,
Joel.
sir, please, you said.
I'm asking if you are looking at the question.
Yes, sir.
Okay. So you have 1 minute to finish looking at it. All right. Time is on our side. Today I want us to also start an inclined plane. So let's see how the question actually goes. So a particle of mass 50 kilogram is caused to slide by a force 450 Newton along a rough surface. So let's have this to be the surface. So this is the rough surface. A mass of 50 kg. And this is forced to move by a force whose magnitude is 450 Newton. Okay. The frictional force. So once for friction, it is always opposing motion. So if the body is moving in this direction, frictional force would act in the opposite direction. Okay. And so the coefficient of static friction mu 0.5. That friction will be at the opposing end. Find the acceleration with which the body moves. So we are looking for acceleration of the body of this mass. Okay. Hey, they are dropping. So who is Epia is here, Janice is here, Joel is here, Epia Watima, whose connection is not stable, is here, and Kenneth is here. 5. Hello, can you hear me? Can you? Oh, okay, I had a technical
Yes,
hit.
sir.
Okay, I had a break, so all right. So you see, I said that if the body just moves, if the body just moves, then if the applied force, let's use P on the applied force, because we have F for friction, so for the body to just move, P must be equal to F. Now, if the body must accelerate, then there should be a difference here. R resultant force is 0. If the body accelerates, P minus F must not be equal to 0. Okay. And the difference between them will be equal to the resultant force. Let me make it F resultant or F net. Okay. And Newton is saying that every acceleration is caused by an external force. It can be resultant force, net force, or unbalanced force. And so P minus F can be equated to M by A, the mass of the body and the acceleration. So if you are looking for acceleration, A will therefore be equal to P minus F over M. Okay, we have 450 F. We have to find frictional force, and we know frictional force reaction. The reaction was the ground G. Time. This will give us 250 Newton. Please, okay. Hello, are you okay?
Yes,
Please, I
please.
don't understand.
So when I'm teaching, you have to give input. If you are not clear, you have to tell me. Okay, you don't let me move only to ask. Where lies the problem? Where are you lost?
You said
are
you are
where?
from the P minus F equals to M times A.
Newton's second law of motion. Newton's second law says that every force, any force on a body, okay, or this can be on a moving body, the mass, product of the mass, and then the acceleration of the body. Every force on a moving body is this. Now, a body can only move when there is a resultant can accelerate when there is a resultant force. When there is a resultant force. Okay. And you see, when a body is moving and the resultant force is equal to 0, the body does not accelerate. Body doesn't accelerate. Every acceleration must be caused by a resultant force. And here, the resultant force must not be equal to 0. So if R has a value greater than 0, if R is greater than 0, then body is said to accelerate. Joe, are you okay with this preamble?
Yes, sir.
So if there are two forces happening here, okay, one moves in this direction, then it means P must be greater than F to move in this direction. Once the body moves in this direction, accelerate in this direction, then it means that this force has my right is greater than what is at my left. So if you put the difference between them, P minus F, the difference would give you what we are calling as the resultant force. When you subtract and the resultant force is not equal to 0, then the body can accelerate. Okay, so we subtracted F from P, and we realized that this is what we have for P, 250. So we subtract 450 minus 250. The difference is greater than 0. The difference is greater than 0. Then it means the body is what? Joel, if the difference is greater than 0, it means the body is what? Per what I've stated here. The body is what? Joel, you are not there. It means the body accelerates. If the body is accelerating, how would you calculate this acceleration? Equate the difference, which is P minus F, to be equal to mass of the body times acceleration, because this is what Newton said. Any force is given by ma. So when you divide through by m, when you divide the difference or the resultant force by m, then you can now find the acceleration of the body. Class, please, are you okay? Everybody.
Yes.
Yes, sir.
Please.
So this is what I'm calculating here. Because of the difference. Let me because there is a difference. 450 for P minus 250 equates to the mass of body is 50 and acceleration. And so you can calculate the acceleration from there, right? 200 is equal to 50 by A. A is equal to 200 over 50. And this is 4 meters per second squared. So Ekweadoma and Boma and the rest of you, this is the acceleration of the body. All right.
Yes, please.
Hey, the late Isaiah. Isaiah.
Yes, sir.
Hey, when did you come?
Sir, long time.
That you watched us a long time. Who wait me up a long time? When we is it clear? Can you read from the board, or I should take a shot and send it to the group?
Stadia, please, I've been able to write it.
Okay. All right. If you're not writing, can I clean the board so we can continue?
Yes, please.
Joel asked a question and he's gone. Hey, ask somebody. Online teaching is not easy. Yo, yeah. That's why it's gone. I don't understand. When I've wasted all the energy to explain. Let's look at motion on an inclined plane. Motion on an inclined plane. Motion on an inclined in JHS, you did inclined plane, and you were made to understand that an inclined plane is a simple machine, isn't it? Or you've forgotten you did an inclined plane.
Yes, please.
So an inclined plane is a simple machine. How is it like? We have a rigid bar. This is, and then this is maybe a wall. And then we have a rigid bar from the wall to the ground. And the angle of tilt between the horizontal, which we are calling as the ground, and the plane is theta. We have formed an inclined plane where this side, the vertical, is perpendicular to the ground. So A, B, C. B, line, line, the inclined plane or of the plane. BC is equal to the height of the inclined plane. This is equal to H. And theta is the angle of inclination. Now, inclined plane is, I have seen this used to load and offload goods. A grab is gone. I have seen an inclined plane used to load and offload goods. Okay. Now, let's analyze the inclined plane. On an inclined plane, whenever you put a body on an inclined plane, if the surface is frictionless, it's always sliding down the plane, or the body always rolls down the plane. So let's have this to the weight of the plane, the weight of the mass on the inclined plane given by mg. So mg is the weight of this body on the inclined plane. When we studied line flux on the ground, we realized that the weight acts at the center. So if this is mg, which is the weight, Newton is saying that forces move in pair. There's also a reactional force R of the same magnitude opposite in direction to the weight. And weight is always perpendicular to the ground. And the reactional force is also always perpendicular to the surface on which the body lies. So weight acts, weight of a body acts perpendicularly to the ground. and reactional force is also always perpendicularly to the surface on which the body lies. So while weight is perpendicular to the ground because of gravity, gravity always acts towards the center of the earth. Reactional force is always perpendicular to the surface on which the body lies. So this body is still, it's not like this one. It's still, so we need to have the reactional force always, the reactional force are not perpendicularly to the surface. So when you determine the angle between reaction and then the area at which the body lies, you must get an angle of 90 degrees at this end or at this end. But as for the weight, it is always also perpendicular to the ground. This is the ground. So from the weight to this, we have an angle of 90 degrees here. Class, are we okay? Are we okay?
Okay.
All right. So there is this relationship, weight and this. Now let's extend the reactional line at the opposite end. When we extend this line of the reaction, and let's call this R prime to distinguish a reaction from this R prime. Now I want us to label this point. We have this point as A. Let's label this point as O. This is BC here, so D. We have D here, and then this is R prime. Okay. If you have are you there?
Yes, please.
If you have are you there? Okay, so when we consider triangle A, O, D, okay, this angle here is theta. Then are you there? This, if this angle is theta, please, what will be this angle? If this is theta, this is
90 minus theta.
good. This will be 90 minus theta, but this is already 90. Okay, this must also give us 90, and the total angle is 90. So let's assume this is A, don't you know? It means that angle A will be equal to, when we subtract theta from 90, it will give us angle A. So A is 90 minus theta. Please, do we all agree or do we understand?
Yes, please.
Okay. Now, what will be this angle between the weight MD and the extended line of the reaction?
Sir, please, 90 degrees.
Come again. No, we are looking for this angle. We are labeling as what will be
90 minus A.
90 minus A. Okay. You see, what will be this whole angle? What is this whole angle? What will be this whole angle?
That is 90 degrees.
90 minus theta.
90 degrees, 90 minus theta. More views. Janice, what do you also think? Janice, what do you also think?
No, 180 minus theta.
Janice, are you there? Okay, let me come in. What is this angle? What is this angle?
That is 90 degrees.
Okay, what do you say? This is 90 degrees. This angle is 90 degrees. So what will be this angle?
$90.
90. So it means that angle A plus X will be equal to angle this angle plus this angle will be equal to what? Yes. Angle A plus X will be equal to plus all of you.
90.
It will be equal to 90. And we'll just realize that A angle A will be equal to T minus theta. So if A is 90 minus theta plus X, this is equal to 90. What will be X? Help me find angle X. Help me find the value of this angle X.
Theta.
Theta. If we have hey. So her line
Mr.
is
Dia,
not
please
good.
analyze mine.
Eh? Oh, she has problem with her network. So X is also theta. What?
Wait, my network went off.
Okay. What we have deduced is that on the inclined plane, the angle of inclination is theta. Then the angle between the width of the body and the reaction, the center line of is also theta. So let me clear this and bring out something for you to see. All that we have established is this. The tilt is theta. Now on an inclined plane, this is width strategy. The reaction is always perpendicular to the surface. Okay. So if when you extend the reaction line, if this is theta, the angle between the width and the reaction line is also theta. So if this is 30 degrees, this will also be 30 degrees. Please, are we okay?
Yes, please.
That is a very important point to understand
Mr. Dia.
under inclined plane. Okay. Now, let's do something. This is width. This is the angle of tilt. Side adjacent to the angle is this side. If you draw a perpendicular line from the adjacent, If you draw a perpendicular line from the adjacent, you have the opposite. You have the opposite. So this side is the opposite. So with this this side, and then we have the width is given us. This side is always perpendicular to the adjacent. So the adjacent, this is. Now we kind of have a width letter MD acting as a function of theta degrees. So we more or less have this kind of right angle triangle. We have a right angle triangle. Okay. This angle is theta. Okay. This is the hypotenuse. This is the hypotenuse acting up, and this is given by mg. Once you have the angle, you have the hypotenuse, this is the opposite, this is the adjacent. It calls for resolution of forces. Resolve this so that we can have the adjacent and then the opposite. So I want you to resolve that vectors. Resolve this vector, the weight, to give me the adjacent and then the opposite. What will be the side? And what will be the side? Yes. What will be the adjacent? What will be the opposite? Okay, what I'm waiting. Kenneth, I'm waiting. And Janice, I'm waiting.
Okay.
Mr. Adria,
Hello.
maybe the opposite will be the reactional force.
You see, this is the opposite. This is the adjacent. And this is the adjacent.
Then the adjacent.
This is the adjacent. The side which is close and the base of the angle is adjacent. So we can locate the adjacent. The perpendicular line from the adjacent will give you the opposite. So this side is the opposite. So
No,
this
the
is the
adjacent.
hypotenuse and this side is the adjacent. The side of the triangle, which is at the base of the angle, that is close to the angle, is what we call as the adjacent. So it's this side. This is the opposite. The opposite is always perpendicular to the adjacent. And then the hypotenuse. I want you to resolve this. Give me the adjacent and opposite resolution of vectors into components. So what are the for the opposite? Kenneth and Ikea, I think you are the only. Janice, I don't know if she can hear us, but she doesn't talk. So you are the only two around. What is the opposite? What is the adjacent?
The adjacent is the reactional force.
Reactional force? No. Ikea, this is what I'm saying. If you have a force, resolution of forces components. If you have this angle theta and you have a force, this is the side which is close to this force touching the angle. So this is the when you look at the perpendicular line, you have the opposite. So you get the vertical and then the horizontal component of this. What will be this part? The opposite. Okay,
Sir,
that's
so can
what
we use the
resolution of forces into components.
sir, so can we use the SOHCAHTOA method?
That's the same thing you have to use. You have the hypotenuse, you have the angle. You are looking for the opposite, you are looking for the adjacent. So that's what you have to use.
Okay.
You are not applying what
Miss
you've learned.
Dedia,
Yes. Agree. So this component, the opposite is F sine theta. The adjacent will be F cos
Cos theta.
theta.
yes, please.
Something we've done on the vectors apply, you can't see. Eh?
I was about
We've
to
done
do
this. We've done this on the vectors. Apply and you are not talking. So if the weight, the hypotenuse is mg, the angle is this. Then this is the adjacent. This is the opposite. The opposite will be equal to mg sine theta. The adjacent will be mg cos theta. So please do get it.
yes, please.
Now, this is the opposite. The opposite side can be brought along the plane. So that the magnitude of this is equal to this. The direction of this is to this direction. And these two are parallel, equal vectors. Vectors are equal wherever they are if they have the same magnitude, direction, and are parallel. So we can bring this end here and we'll indicate this as mg sine theta. This is also mg sine theta. Please, are we okay? Are we okay?
Yes, please.
We are applying what we've learned on the vectors. Kenneth, are you okay?
Yes, sir.
All right. If that is the case, then when you look at vertical equilibrium, this side is equal to mg cos theta. So we will see that vertically, the reactional force R is equal to this component, which is mg cos theta. And this is the component of the weight which is equal to the inclined plane. So this component, let me write it before. Component of the weight perpendicular to the inclined plane is mg cos theta. AB is the inclined plane. So we realize that this component of the weight is mg cos theta is perpendicular to the inclined plane. So that's it. A component of the weight which is parallel to the inclined plane. Component of the weight parallel to the plane, to the inclined plane. And what is the component parallel to the inclined plane? That
mg sine theta.
is mg sine theta. So if you are asked to determine component of the weight mg perpendicular to the plane, it is mg cos theta. parallel to the plane, it is the mg sine theta. Correct? Please, is that okay?
Yes.
Now, if we look at vertical equilibrium, total upward and downward forces, we realize that if we look at vertical equilibrium, you could see that the reactional force is bound by this component of the weight. So R is equal to R, which is reaction, is equal to mg cos theta. So on an inclined plane, the reactional force R is given by mg cos theta. When the body is flat, lies flat on the ground, the reactional force R is simply equal to mg. So here we say that R is equal to mg. But when the body is on an inclined plane, the reactional force is equal to mg cos theta. Mg cos theta. So take note of this. Please, is that okay?
Yes, sir.
Yes, please.
Do you follow what I'm discussing with you? Right?
Yes. Yes,
Now,
please.
so vertical equilibrium, we realize that R is equal to mg. Let's look at horizontal equilibrium. Horizontally, horizontal equilibrium, we realize that the mg sine theta has no answer at the other end. So this is we add the other component over here. Mg sine theta is down here, but mg sine theta is here, but there's no other forces. So it says that this is unbalanced. Unbalanced. And whenever there is an unbalanced force, body accelerates in the direction of the unbalanced force. Because mg sine theta is only force here, and there's no force up there to balance it. This is the reason why whenever you have a inclined plane and you put a body, it is always rolling down the inclined plane. Okay, because of the fact that mg sine theta is on at the other end. When you put a body on an inclined plane, it is always going down the plane because this force is unbalanced. It is always placed on an inclined plane down the plane. Please, you understand it?
Yes, sir.
So the mg sine theta component of the mass, of the weight, always accelerates bodies down an inclined plane. So bodies accelerate down an inclined plane due to the mg sine theta component. So that is the reason why bodies are always accelerating down an inclined plane. So which force is If you are asked which one is responsible for accelerating bodies down an inclined plane, it is the mg sin theta component. Simple. If you have any question, ask. Any question? Do you have any question?
No, sir.
All right. So my question to you is that which force is responsible for acceleration of bodies down an inclined plane? Yes, which force is responsible for acceleration of bodies down an inclined plane? Yes, Clement.
Yes, sir.
I said which force is responsible for acceleration of bodies down an inclined plane?
Horizontally equilibrium.
So what is the force? What is the force?
Sir, force of gravity.
What's the force of gravity? I gave you the force which accelerates body down the plane. So which force of gravity? I said the force which accelerates body down an inclined plane is equal to this, the mg sin theta. Right?
Okay.
It is a component of the weight which is parallel to the inclined plane. So this is the reason why this is what causes bodies to go down an inclined plane. All right.
Okay.
So if the next force which is always rolling down a body down a plane is this, then we can find acceleration of bodies on an inclined plane because F net force is equal to any force. This is unbalanced. Okay. So the unbalanced force is equal to mass times acceleration. Newton says it. So when we put mg sin theta, because that's the unbalanced force, and then equate it to m times a, we can find the acceleration of bodies down an incline. Okay. So
Yes, sir.
m will cancel. Therefore, acceleration a will be equal to g sin theta. So for bodies, if a body rolls down the inclined plane, and you are asked to calculate for the acceleration is equal to gravity times the sine of the angle of inclination. Is that okay? And if you are asked to calculate the force which is pushing or accelerating bodies down the plane, that is mg theta.
Okay.
Okay, your line is still not stable.
Hi,
I
MG.
can hardly
So
hear
I'm
you.
asking why unbalanced.
Pardon?
Asking why is MG sin theta unbalanced?
I said you don't stay in class. If you stay in class, you will know. Eh? Either. Okay. Wow.
So there's a network.
It's a network. If the network is behaving like, how would you understand what I'm doing? Are you there? Okay, are you there?
Yes, please.
It's
Yes.
unbalanced because when you look at vertical equilibrium, this component of the force of the weight mg cos theta has its balancer. There's another force. Let me get something to illustrate this simple. You see, on the body, we have one force mg cos theta acting down the plane. Up the plane, we have r. So the reaction is balanced by mg cos theta. So vertically, these two balances. So these two are balanced. Agree? Are you okay?
Yeah.
Vertically,
please.
these two are balanced. Now come to look at the horizontal. But there is no other force at the opposite end. It's not like what we have vertically. So this one, mg sin theta, because it has no component here, we say this is unbalanced. Mg sin theta,
It have a component there because the cos theta also, like you made it have cos theta, like the minus cos theta.
I don't get you. I don't get your question.
So you created like cos theta for the r. So can you also create an opposite end for the sin theta?
Yeah, okay, I created. We resolved and then saw that the component of the weight mg, okay, the different component of mg will be mg cos theta, the opposite component will be mg sin theta. And because of equal vectors, we have mg sin theta here equal wherever they are, if they have the same magnitude, direction. So we created an equal vector of this and placed it along the plane. And also mg because they are equal vectors. Do you get it?
Yes.
So I think this is because of the fact that this weight is resolved. So we have the adjacent mg cos theta and opposite mg sin theta. Okay, so when you do realize that vertically this will be balanced, r will be equal to mg cos theta. But horizontally, mg sin theta is unbalanced. There's no component here. And this is the reason why on an inclined plane, whenever you put a body on an inclined plane, it's always going down. Because this looks like a force which is always there, which will push down the plane. So you place an object on an inclined plane, it's always accelerating down the inclined plane because of the mg sin theta component.
Okay.
Are you okay?
Yes, please.
Kenneth, are you okay?
Yes, sir.
All right. Today's class, you people didn't make me enjoy the class. You didn't let me enjoy the class at all. This one is going off. This one has network problem. This one will not talk, and it makes the class difficult. So this is where I draw the curtains on today's meeting. We'll continue on when your network situations are stable.
Please, I have a question.
Until then, I will answer your question.
Yeah, it's just about a reactional force. Like, what is it?
Reactional force. What is it? We started a body on a flat surface. And Newton is saying if there's the weight of the body, forces move in pairs. Forces move in pairs. So if this is the weight, there will be an equal force, equal and opposite to this, but acting in the equal in magnitude, but acting in the opposite direction. So this is the weight, this is the reaction. So reaction is the other force which will balance the weight. Okay.
Okay, Mr.
Forces
Yes,
move
please.
in pairs. So if this is the weight, there is a reaction. The reactional force is always perpendicular to the surface. It means the weight is the actional force. So we have action and reaction. Forces move in pairs. Okay, so that's the twin of the action force. But so basically that is reaction. Okay, reaction and the main force is equal force which we are calling as a reaction. All right, so we'll continue on Friday. But fix your network before we start. Ebria Watma, you were calling.
Please, after the class, can you send me the video?
I won't mind you. Good night. Bye bye. I won't
Bye.
send you the
Did you